Hey, this is chapter 11. It's about a metal casting process and some related equipment. In the previous chapter, we have discussed the fundamentals of casting processes, how actually materials are casted, how they're solidified, and what happens if you have high solidification rates or low solidification rates. But in this chapter, our focus will be more on the type of metal casting operations, and we'll briefly discuss some equipment which can be used in these processes. And as you see, you're only responsible for the first four section, and you're not responsible for the remaining ones. But the first ones are more important. The rest are some details. And with casting, as you know, we can produce different types of products, smaller ones, larger ones. And here we have some examples, engine blocks, some blades, turbine blades, some even zipper teeth, some dies, molds for different operations. They can all be manufactured with the help of casting operations, and our main focus will be on metal casting, not on plastics or other materials. We discuss some casting operations for plastics in the previous chapters, but in this one, our focus will be on metals. And there are different types of casting processes. You can see again in this table that there are such processes, and we are going to discuss all these in this chapter. And we may have a kind of a classification in terms of type of materials we are using for the mold, type of pattern production, what type of patterns we are using, templates, and what how the molds are manufactured, and how molten material actually is feed into the cavities. So there might be a difference in terms of these actually aspects, and let's discuss them briefly. In this first classification, actually, we have the expandable molds, which means that the molds are not used for the second time. They are only used for a single casting operation, and for the second casting operation, you need to prepare a new mold. And on the other hand, for permanent molds, as the name implies, you can use them for a longer time, for many times, maybe about 1,000 times, depending on the quality of your mold. And in the third, actually, classification, we have the composite type of molds in which actually you make use of different type of materials to manufacture your mold. Now let's briefly discuss these types one by one. In the expandable mold, we make use of mostly sand particles, some plasters, ceramics, so that they can easily be collapsed and we can take our actually cast products. And on the other hand, we need to actually, since we are trying to manufacture, obtain the mold, these particles, these little particles should be stay together. And for that purpose, we make use of some binders, and they're not obviously too much, but we use some amount of binders to hold these actually powders together, and this is called actually as cohesiveness. It's actually ability of our mold to retain its shape after all these operations are performed. And another thing we want actually from our mold is that it should be able to withstand to high temperatures, since metals will be the liquid metals will be in at high temperatures. So that's why our mold should be able to withstand to these high temperatures, and that is called as refractories or refractoriness. Uh, your mold material, your particles, powders should have high refractoriness so that you can easily cast very difficult metals having high melting point temperatures. And in these molds, sometimes we will be using patterns of if the shapes are complicated, and depending on your case, you may not be able to use a pattern again, or you may use the same pattern in your different application. Although the mold is expanded, but still you may use the same pattern depending, as I said, on your specific needs. And if that is the case, that is called as actually the process expandable mold permanent pattern casting processes. But in some cases, the pattern may also be actually evaporated or removed, collapsed, and that if that is the case, then it's called as expandable mold and expandable pattern processes. Now let's have a look at the second case, the permanent molds. And in these permanent molds, they are all made of metals so that they can be used many times after each other. And with the help of it, the casting is much easier. We have the mold ready. We don't need to worry about remanufacturing the mold. And they are usually better heat conductors. They use some channels inside. And we have a high quality product actually with the help of these permanent molds. And due to use of actually these extra cooling channels inside, they have higher rate of cooling. And with the help of it, we can have finer grains. And as you know, if you have smaller grain sizes, then the strength and hardness of the product will be a bit better. And the last one is not that complicated. In the composite ones, we make use of different, let's say, materials to manufacture their molds so that we have more advantages, more better properties regarding the molds. And in such cases, again, we may have some permanent parts and some expandable parts. It depends on your design, it depends on your approach. Let's continue with the first main type of metal casting operations. This is expandable mold permanent pattern processes, which means that we cannot use the mold once again, but we can use the same pattern in our next casting operations. And in this category, actually, we'll be talking about sand casting, shell mold casting, plaster, ceramic, vacuum casting type of operations, and they all are kind of an expandable mold and permanent pattern casting processes. So let's focus on the first one. It's actually sand casting and one of the oldest type of metal casting process. As the name implies, we are using sand particles to obtain into our mold, and then once you have it, then you can do the casting operation. Now let's briefly look at the steps of the sand casting operation. So what we do, you need to first have a pattern, and then you actually put this pattern into your kind of a box and obtain your mold. And then later you remove that pattern. If you have two molds, let's say halves, you join them together and then have some gating system. These are, we will be talking about these issues. They are important in terms of material flowing through these actually parts. And then we simply remove the pattern and simply pour our molten metal into these cavities. Then later, wait for some time, then the metal will be solidified, and to the end of the process, we break the actually mold and remove our casting. So in this casting, as I said, obviously, as the name implies, we are using sands and sand particles. They are, as you know, silica sand. We have silicon oxide inside, and these are very inexpensive, highly inexpensive materials. That's why we mostly use sands in this casting operations. And another important issue is that important property of sands is that they have high melting points, so it's highly suitable for casting of metals having high melting points. We may make use of naturally bonded ones or synthetic ones, since in the synthetic ones you can play with the content of your sand. That is better for better accuracy, hardness, and strength of your mold. And another issue regarding the sand particles is that there's a kind of a trade-off. If you use actually smaller, let's say, sand particles, then your surface accuracy is better. As you see, the surface roughness is less. But the thing is that we have less permeability. But on the other hand, if you have larger workpieces, larger sand particles, your surface roughness is high, but on the other hand, your permeability is quite fine. So that during the casting operation, if you have some gases generated, they can easily be removed from your mold, and you are not going to have any porosity, any problems inside your casting. So you should find a moderate size of your sand particles, and that will give you some acceptable permeability. So this is a nice actually pipeline of sand casting process. So what we do, we have sand particles, sands, we have the pattern. By using them, we prepare the mold. And during this time, we also liquefy our material, and then pour our metal into the cavities of the mold, and then the metal will be solidified. Then we will simply remove the casted product and remove the extra components like risers, gates. And this is an example here, as you see. This green one is the actual product we want to have at the end of the casting process, and the other ones are for better casting. We will discuss the functions of these, but at the end of the process, we don't want to have these gray parts. So what we do some cutting, sewing, so that we only left with the green part. And later, you may do extra heat treatment, extra finishing, cleaning operations, and lastly, you can check whether there are any cracks, any defects, any wear on your casted product. So this is a typical pipeline of sand casting process. Yes, now let's discuss the fundamentals of this actually sand casting mold. You see at the outer part we have a kind of an box shape. This is called as flask, and it's mostly made of wood. And then inside this flask we have two parts. The upper part is called simply as cope, and the bottom part is called as drag. And this blue one is actually the part we want to have at the end of the process. And you see this is a cross section, so we have a kind of a circular shape, and this is only showing the two sides of our shape. And at the center, you see we have a kind of an, let's say, another pattern, but this is actually capped inside your mold during the casting operation. I will talk about the function of it, but right now keep in mind that if you want to have such hollow shapes, some complicated shapes, then you need to make use of such cores. And how we actually pour the molten metal, for that purpose, we have a pouring basin here. We pour our molten metal into that, let's say, kind of a basin, and then it moves through that sprue, and then we have a kind of a well here so that we don't have much turbulence in the liquid metal, and then we have some gates. This is an actually inlet to the cavity, and then we have a kind of a roadway to the cavity here. You see the material moves from this sprue and then into the gate and runner, then it goes into our cavity and it fills here, and later once you actually pour some enough amount of material, then you will wait for some time, and then that will be solidified and you have your part ready. And another thing, important thing, is that the rises. If you remember from the previous chapter, we said that once these actually molten metals are solidified, their size will be decreased. We will have shrinkage. In order to compensate this shrinkage, what we actually provide some extra material so that in this risers we have extra material, and once your product is getting smaller, they will be satisfied, actually supplying some extra material. And that might be in a blind version. So you see it's not open to air, it's called blind riser. But if it's open to air, then it's called as open riser. And lastly, we have such vents at some point so that if some gases are generated, then they will be actually removed from this environment with the help of vents. And another thing actually regarding the sand properties I didn't mention is the collapsibility. We want actually these sand modes to be easily collapse after the product is actually solidified. So this is an important issue. And another thing about the collapse is that while this metal is being actually shrinking, getting smaller, then your sand particles should allow the material actually to shrink. Otherwise, if you remember the previous chapter, we may have some hot tears on the side walls, on the surfaces. So this is another advantage of good collapsibility. So in summary, We want actually our sand to have some amount of refractoriness, cohesiveness, permeability, and collapsibility. If you have all these, then you will have high quality products in your sand casting operation. So what type of actually sands we can use? There are three types. The first one is called green sand, then we have cold box, and lastly, no-bake molds. And in the first one, this is a typical one, the most commonly used one. What do we have? We simply have sand, clay, and water. So with the help of these, actually, we have some amount of cohesiveness, and this is much simpler, much actually cheaper compared to the other ones. But in this one, sometimes you may need to actually dry it in some simple ovens. But in the cold box version, that is not the case. You don't need to use extra ovens. You don't need to heat them. What you do in cold box molds, you make use of some binders so that the strength is a bit improved with the help of them, and their accuracies are much better compared to the simplest case, compared to the green molding sand. And in the no bake molds, as you see, obviously we have no baking, no actually heating. In the previous one, that might be little, but obviously this is less than the baking we have in the green molding sand. So this is actually summarizing the things I discussed in a moment ago, but I didn't mention about the cores a lot. So let's briefly talk about the cores. You see, in such hollow shapes, if you have some holes or blind holes in your casted product, then you must actually use such cores. And they're again made of sand particles, but the thing is that their strength is a bit higher than the strength of the other regions, since once you collapse them, or once you have actually high pressure, and they shouldn't be collapsing, otherwise your shape wouldn't be hollow anymore and you'll have problems. And as opposed to the patterns, actually these are, as you see, staying in the mold during the casting operation, but the patterns are removed before pouring the molten metal. And actually I talk about the vents, and let's brief talk about the patterns. Patterns are highly important, and we make use of them actually to obtain desired shapes, desired dimensions. And they may be made of simple wood, plastics, it doesn't matter, since these patterns are not actually stayed in the mold during the casting operation. We remove them before we pour the molten metal into the cavities. And there are different types. We may have, for simpler shapes, we use one-piece patterns, or for complicated ones, in order to increase accuracy, sometimes we may use such split patterns, or we may have match plate patterns. You can see an example here. It's much more professional than the simple ones, wood ones, and in some cases, we may be using some special manufacturing process to obtain these patterns. Even we may use the CNC machining, we may use rapid prototyping, additive manufacturing to obtain these patterns so that the cavities, the shape of our mold is proper. Another issue regarding the patterns is that you see this is the here you see an example of a sand casting operation. This blue ones are the patterns. So what is done here? Our desired product will be in the shape of this pattern. So what we do, we shape our sands, actually mold with the help of this pattern, and then later, before pouring the metal, we remove these from the mold. But if you keep these angles at 90 degrees, then what will happen? You'll have too much friction and you may actually collapse some regions of your mold. So that is not designed. So what we do, we have some little angles, and these are called the drift angles, so that once you are removing the pattern from the mold, the shape will not be modified a lot, and the overall accuracy of the casted product will be a bit better. And we also need to consider the shrinkage, the amount of shrinkage in the patterns. So they may be a bit actually larger, since our material will be shrinking. And once it shrinks, it should actually approach to the desired dimensions. And now let's have a look at another example of cores. In some cases, we need to actually support the cores. Otherwise, you cannot keep it in that complicated shape. And these are called as prints, core prints. As you see, this is our core, and the material will be poured actually in these cavities. These white regions will be filled with molten metal once you are doing the casting operation. So we will have a kind of an cylindrical shape and with a hole inside. And as you see, this core is supported from both ends. And if you have a blind hole, as you see this time, the shape is a bit different. You cannot support your core from the both ends. And if that is the case, so what we do from one end, we may be supporting them by again using the prints, by using the shoulders of the mold, but the other ends should be actually supported with different tools, and these are called as chaplets. So you see, these are kind of nails, some kind of balls, so that the position of this core is actually stabilized. It doesn't vibrate, doesn't move, and the quality of the product will be improved. And the thing about the chaplets is that since you will be pouring molten metal, so it's better you use the same type of material with the liquid metal, since that will be kept actually inside the product once it's solidified. You cannot remove it once the casting is over. And in order to actually manufacture or prepare these molds, sometimes people use some special machines with the help of them. The production, the efficiency, the number of products now they are casting is increased. And you can see an example here. What they are doing is that they actually prepare these molds after each other. And once they are actually joined together, you see we have such a cavity, and material will be poured into that cavity, and at the end we will have such a shape. Now obviously during this process we need to make use of such patterns. You see, once if you consider this part, the intermediate part, one side is actually obtained with the help of this pattern here, and the right hand side is obtained with the other pattern. So we make use of obviously some forces to shape the sand particles, and if you do it repetitively, then you see we have a continuous actually discrete cavities in the sand, and then later with some other equipment we can pour our molten metal. And for simple ones, people sometimes use sand cylinders so that the powders are actually joined together, their strength is improved. I will show you some examples about these, but they're not that complicated. And here you see a nice actual summary of the sand casting operation. Let me briefly talk about the steps here. Obviously, at the first stage, you need to design the part. And if you look at this part, as you see, it's a kind of a tube shape. So obviously, we need to make use of a core. If you don't use a core, then this interior will be filled with material, and you cannot have such a hollow shape. So core is a must in this casting process. So in the first row, what we do, we usually prepare the patterns for the cup, the bottom part of the mold. We prepare the pattern for the upper part, or lower, I'm sorry, they may be mixed actually. And then what we do, we also prepare the core, which is, as I said, the most important part in this casting operation. The center, we prepare it by using some special boxes, and you see, once you have the two halves of this core, you join them together by simply using adhesives, and that will be utilized in the later stages of the casting process. And then what we do, we first prepare the cup, the upper part of actually the casting, the mold. You see, we place simply the pattern underneath here, and then we place the sprue risers, some other gating systems. They are all actually prepared at this stage. And then later what we do, we pour sand into this cavity, into this flask, and we apply some little pressure, and then later all these actually patterns and these equipments are removed, and we only left with sand, but it has obviously some cavities which are useful for the casting operation. Then we do the same for the drag side, which is actually the bottom part of the mold. As you see, we make use of the drag pattern, and then we simply pour sand over it and then shape it. Once it's shaped, actually, we simply remove our patterns so that we are going to use these patterns in the next casting operation. So you see this part is ready. This is drag, and drag is the bottom part. And now this is the stage actually we are using the core. And so what we do, we simply place this core at the desired location into our drag, since we want to have an actually hole in this product, and that will be obtained with the help of this core which was prepared in the previous stages. And then later what we do, we place this cop and drag on top of each other, and we don't have any other patterns, we only have inside this core. Then what we do, we pour our molten metal, and once you remove your cast product, you also need to remove this core, or if it's not removable, you may maybe even break it if it's not possible to remove easily. And later, you do some machining and some extra processing so that these parts are removed and you only left with the casted product. And in addition to actually sand casting, we also have other expandable mold and permanent pattern processes. This first one is after the sand casting is shell molding, and the advantage of shell molding is that the accuracies, tolerances are very high in this process. And if that is the case, if you want to have actually at the end of casting process, you want to have high accuracies, high quality at the surfaces, that is actually approach you should follow. And again, I will show you some examples of this process. We have an example sketch here. So what we do, we have again a kind of a pattern. And then what we do, we place this pattern here, and inside this tank, as you see, we have some coated tank. And by the way, we have some actually adhesives inside also on this side of this pattern. And then later we turn it upside down, and the sand particles actually will be sticking to the pattern. You see now, initially it was gray. Now with the help of these blue particles, we have done some kind of a coating. So later you can simply remove the pattern and only left with the shell. So this is a very simple process. And if you repeat it for 2 times for 2 sides of your mold, then you obtain these actually let's say shells, and that's why it's actually called as shell molding. And then later what you do, you clamp these together, put it into your flask, and then you can pour some sand particles inside here. But you see we have a cavity, and then later the rest is not difficult. You can simply pour the metal, pour molten metal into it, and do the casting process. And this is actually much better in terms of, as I said, dimensional accuracy, and it's also better in terms of time. With less labor, with less time, you can obtain this products. So for mass production, for high numbers of production, shell molding is preferred actually over sand casting. Then we have plaster mold casting. As the name implies, we are using plaster, and this is again for high precision. And the upcoming one is also another casting process where you can obtain highly precise products. And the difference is that in this one, we are making use of plaster to prepare actually the mold. But the rest is very similar to the previous ones. Again, we need to have a kind of a pattern, and then around this pattern, we pour our actual plaster. And then later, once it's actually solidified, we can make use of it as a mold, and at the last stage we pour the metal into that cavity and obtain our product. And we have another similar process to the previous ones, like expandable mold and permanent pattern. This time we are making use of ceramics. In the previous one, we were using plastic, but this time we are making use of ceramics. And the thing is that with the ceramics, we can cast actually difficult metals having very high melting point temperatures, and this is mostly used for these purposes. And in order to increase actually the strength of the mold, sometimes we may do extra burning off so that the strength of this mold is further improves and you have much better high quality products.